So we're talking about testing, past, present, and future. And it's not everything you wanted to know about past, the present, or the future, but mainly it's things that we've changed as time went on. So the goals that we have, we identified a few that we have for testing. Testing that new code performs according to requirements. That is typically done by the developer writing the tests. Test that new code doesn't break existing code. The tests that we run hopefully show that. Test that new code doesn't adversely affect performance. I'm not sure how well we test that, but it's definitely something we're interested in. And testing the design limits and data characteristics, as in the type, the size, and so forth. So that's what we came up with. The past from 2008 to 2024, there was past before that, and there's a couple of people on the call that would know better than Alan or me what happened back then. But I think when the group was part of NCSA instead of a separate company, it was mostly on NCSA machines that testing was done.
Well,
I could be wrong, but that's what I expect.
It was entirely hosted there, of course. Yeah.
Yeah.
But it was similar, just
Right.
the scripts.
Well, and from then up until a couple of weeks ago, there was similar testing going on. A couple of weeks ago, when we took Auto Tools out of the develop branch, then it became strictly CPINC, which is different than what you had back in the 80s and 90s.
Sure. There were no
So,
80s.
I'm sorry. Okay, originally it was tested using shell scripts. Tests were run using shell scripts and on both big endian and little endian machines, Unix. It was also tested on Windows systems at some point. I'm not sure if that was in the beginning or if that happened in between 2008 but early on then, using Visual Studio to build and .bat files to run the tests. It was a little bit clumsy, I think, or hard to deal with. Then the CMake build system was added for building on both Windows and Linux, and later on other systems as well. The advantage there is one build system can build for both, or generate build files to build on both Windows and Linux. Later, we expanded that system to run tests on Linux VMs as well as Windows VMs. And the advantage there was to be able to start from a clean image that wasn't being used by other people and didn't have things installed that might be unexpected. Later, a few years ago, or maybe 4 or 5, 6, I don't remember when exactly, BuildBot was used to build and test HDF5 on Windows using VM servers and also on Mac OS X and later Mac OS machines, and later still on AWS EC2 Windows and Linux instances.
May I
add? Absolutely.
So I should add that we always, as long as I remember myself at the HDF Group, we were using NERSC to test. Sometimes it was manual, but then it was definitely on schedule, and also some big machines where we can get access to. So it was Cray systems at Cray. There were systems at national labs. There were systems at NASA. So we tried to test on all available systems, and people were very helpful in providing us with accounts. But it was kind of semi-manual, of course, but usually before each release, we tested all those systems.
Yeah, and I mentioned that here in the present. I didn't think about when it happened.
Oh, it happened. It happened even with HDF4. HDF4 was
Oh.
tested at NERC. Mhm.
I see.
That's
Okay.
how I knew how to run bad job. It was from that time.
Yeah. Okay. So at present, we are using GitHub runners with the YAML workflow files instead of build.bat. And the runners are for us free, which the EC2 instances were not. And also those runners install software without us needing to update the software and keep it updated. HPC machines, we run either scripts or GitLab to run the CMake builds and the batch jobs, which run ctest, which is what Elena was referring to. Results are now reported to this URL. It's my.c-org in the HDF5 project. So basic C-info is build errors and warnings, whether tests pass, fail, or are not run. There's other information there that can be useful, which I am going to show you on C-. So configure errors and warnings, build errors and warnings, test, fail, pass, not run, and time. But if you haven't seen these, there are also these notes, which have various things that go into the configuration, the config.cmake file, this ctest script.cmake file, the cache init, which sets a bunch of options in configure options, and this skip test.log, where we put, if we're skipping a test, we try to put a note here as to why. So there are a couple of Fortran tests, a few Fortran tests that fail with CCE from V16 on. We started putting the modules that we're using in this notes file. Otherwise, we aren't entirely sure what modules, all the modules that are loaded, but here they are. And the ctest command, this runs the configure, build, and test for the particular build. So you can also see the configure command by clicking on the first column under configure. The top box here is the options that were in the CMake configure command. This is the configure output. Yeah, so that's that. Unless arrow.
Larry,
yes.
click on one of the warnings too. The nice thing about C- and that going up there is that it will parse the output and pull out just the warnings. So it's a lot easier. If there's a little plus sign, shows you the actual command that it used to build. So right underneath the name of the file, there's a little plus in brackets. Go over to your left. Yeah. See a little plus right there? Yeah, and that will show you the actual command line that it used. So that's kind of nice. You don't have to go searching through a big log file. It will pull these out for you.
So is that the same as in the configure errors column?
I'm not sure. I know on warnings it is.
Yeah, I'm not sure either. I'll check that sometime. Not right now.
But it is kind of nice if you're wondering what flags it actually used. Command it used. It's kind of nice.
So I noticed when I was preparing this that we have approximately 23 to 25 tests that aren't run. And I was thinking there didn't used to be that many, and there didn't. But the reason is the configuration did not specifically enable zlib, which up until recently was the default to be enabled, but we've switched it to not be enabled. So that's why all these 23
Why is it
tests
not-
don't run.
ZLab is so basic. Why not?
Yeah, what was the reason?
I think the reason was that some of us felt if you enable it and it's not there, that should be an error, a configure error, because otherwise you'll have build errors later on, or test errors.
And this is
And
this is wrong because it's optional filter and it should say, okay, I don't have a filter and not fail.
Yeah, right. I mean, if configure doesn't detect it, that's, well,
Yeah,
if you
it's-
asked for it and it doesn't find it, that's a configure option or error. Sorry.
okay, noted. I'm not promising anybody will change.
the biggest thing that it was default for 25 years and people may not be aware now. So this is
Well, it definitely needs to be, because I didn't notice it and I knew, right? So it needs to be very prominently mentioned if we stick with that.
And with gzip, there was, at least when it was introduced, the idea was that even the library is not available, you can create data set with gzip and then write compressed data later on the system where it has gzip. I remember it very clearly from 1998. So it never failed, and filter itself is optional. So data will be written uncompressed if filter is not found.
Okay. Anyway, so this is the one that I fixed, and there are no tests that were not run. So that is all it needed, was enabling zlib. Okay. Any questions at this point, other than the big one about zlib?
Just a note, szip was a different story. NASA specifically asked configure to fail if szip is not available. And there were two differences. Configure always reported if encoder and decoder are available or only decoder is available. And tests never passed. They were adjusted to run within those boundaries. But configure, because szip was kind of required filter, configure was failing not only at writing stage, but at configure stage, because they wanted to build it with szip and know if it's not found or there are problems.
Okay. Oops, went the wrong way. All right, future from now forward. And there are questions here which are somewhat rhetorical questions. Although comments are welcome. And I'm sure there are more questions that are not here. But we start with where we are now, testing CMake only, and continue testing of dependent software, some of which are CGNS, EOS5, HDF EOS5, H5 Pi, MaxIO, NetCDF4. We, I think, want to think about adding better performance testing. We will be expanding external testing of external projects to iWarp, plugins, balls, and pretty much anything else that comes along. One purpose of doing that is when we make a change to develop that's going into a release, we want to find out how it's going to affect those projects before the release and not after.
Plugins, you mean like filters for compression and stuff?
Yes, Alan?
Yeah, just everything like that. Any, projects that are dependent upon HDF5, we try to test if we can in the workflows. So we're aware of any issues that might pop up, and we can, hopefully contact them and figure out, is it something they need to change or is something we need to change?
But
Catch things before the release.
No, yeah, that's fine. I just was trying to figure out what plugins meant, because
Oh,
all connectors are plugins in
right.
an abstract sense. So just filter.
Oh.
Yes, got it.
Yeah.
How about
That is
also
interesting. People have seem to, because filter plugins were there for a while, I think people have tended to, use plugins to mean filter plugins when it should mean vols and VFDs too, right?
yeah, well,
Yeah.
what about spec? How spec is tested? Packages in spec that depend on HDF5. Are we still working with them, or? And if there is develop or some snapshots in spec package?
There is a develop in the spec package. There are, several develops, although I think develop maybe out of date because they wanted a version on develop because it interfered with other packages.
Right, so it's
when
like
it was just developed.
right?
So it needs to be developed -2.0 at this point, or 2.0.0. I'm not sure we've made that change. We haven't heard about it, so probably nobody is using it. But if we haven't made the change, I will make a note of that and check it. I will do that. I mean, we had a develop dash 1.14 or 114 so that we could test the 114 branch with spec.
Two more suggestions. I think it would be great if you could add the Hi5 C++ wrapper, since HY Pi is in this list.
Yeah, actually, I actually have had a pull request, or is it still out there? That actually it's not out there anymore. I had a PR where I actually allowed you to choose Hi5 and integrate it in the build and allow you to package it up and everything. But it was my interpretation of a requirement that Dana had given me to add Hi5, but he just wanted Hi5 testing. I think I took it a little too far.
It's a nice suggestion, but yeah, just testing would be good. So there's that. There's also a Rust wrapper on HDF5 and a lot of visible interest, let's say. I'm trying to be generic at this point, in Rust for HDF5.
Yeah, and those are things that we need to know about, is what are people using out there, and can we add it to our workflows to test it?
Well, but guys, you have to be careful here because how well, like H5, there is a lot of activity going on, right? And we know developers, so they will communicate with other packages, how actively they are supported and how much they depend on non-released version of HDF5. So
Okay.
they can be difference between when it is tested for release versus when it's just regular CI testing.
Right. Yeah, and I think currently we were testing Julia, but something happened, and I don't think we've re-enabled that yet. But it allowed us to at least be aware of issues.
Okay, so the last bullet, how do we make it easier? This is very much related to the zlib question. zlib question. If we're going to keep it not enabled by default, we need to make sure we do that. And then, so AI is with us, and we've written a few scripts and workflows with it. Some other questions: can it help us write better tests? Can it help us discover gaps in our testing? Possibly, if we ask the right questions, and if it continues to develop rapidly. We maybe we'll think about reorganizing testing by types to target particular use cases and increase the testing efficiency so that you wouldn't have to run all of the tests if there was something you're particularly interested in. There are ways you can do that in CMake with a regular expression skipping certain tests, which is, I mean, if you look at those notes, I think you can see what we've done for them. But we generally just skip one or two and not a whole.
And there are CMake does have options that are at different levels of the testing. You know, you can test serial, you could test just parallel, you could test just tools, you could not test subfiling and just test, you know. So there are some other combinations that could be added.
Yeah. So can AI help us do that? Do we gain enough efficiency to make it worthwhile, or is it just it's pretty much the same? Takes the same amount of time, so it doesn't.
No.
If it's minimally a minimal gain, then it's probably not worth it.
It'll help create new tests, maybe analyze gaps, but I don't know that reorganizing it.
Yeah.
Just two comments. First of all, on eHack on May 27th, we invite the speaker who works with AI in application to software development and engineering. So I ask her exactly the same questions. So she will try to look at HDF5 and answer with regard to HDF5, but maybe it will be more, it definitely will be more general talk. Another thing is that I don't know if Jordan talked to you, but when we working on multi-threading project, we updated. He created a document about testing and including multi-threaded tests, and some suggestions how you write the test so make this more efficient and better engineered test suite. So maybe at some point we can bring it this forum, and HDF Group definitely it's useful document. Talk to him. If it's not in your repo, it should be. It definitely in ours.
Okay.
So it is intended for HDF Group. So because we were asking for guidance, as you know, right? How to write and what the rules are, because we can run multi-threaded tests forever. So how to write them? There are different controls and exactly controls on which test to run and so on. So now long document, but nicely written.
Okay, thanks.
I also would
Go ahead.
suggest to, I think this happens, but I don't see it mentioned here, testing against the head, the develop, branch of MPitch and OMPI, so that we can give them feedback quickly when they do something that breaks something that we need.
Yes, we do.
Okay.
It's actually on a daily build. We Jordan wrote 2 workflows that go grab MPish and OpenMPI development branch and compiles that and runs.
Awesome.
There a lot.
That's great. That's cool.
What about Dell's connector?
I don't think it, well, unless you're going to run it at Argonne.
Is it tested or not?
Certainly not on a regular basis.
Okay.
So I don't know if it's Aurora. I don't know if, the machine is working, I guess, but I'm not sure if we have access at this point.
No, and there were several releases of Dell software already, so it may be behind.
Okay, any other questions or comments?
And we also welcome General's HDF5 questions as well, if anyone has any.
Yeah, I have a general question. We're working on a problem here where we have a C code which uses HDF5 and it occasionally seg faults on us. And it seg faults in the HDF5 code library. But we're pretty sure it's not the HDF5 library that's at fault. It's something else in our code that's probably overwriting an aspect of the HDF5 data, and that later on causes a seg fault. And I'm just wondering if there's any advice for tracking down a problem like this.
Valgrind?
What was that?
Sorry, Valgrind?
Valgrind? I think I tried that. And it seemed like it was going to overwhelm the resources of the Valgrind runs as a simulator, right?
No.
Okay, we did try using a package called Duma.
Not familiar with that one. Okay, yeah.
But that basically instruments it inserts kind of unwritable blocks between every memory allocation, I guess, so that if you overwrite a buffer, you immediately get a seg fault. So I think it kind of does what Valgrind does, but in hardware, except that the program itself just once you instrument it, it just demands so much resources that it slows down or it overwhelms the machine it's running on.
Now, Valgrind is pretty close to the hardware, but on the other hand, it does limit the machines. It's really, really difficult to get working for an MPI job. It's possible.
It's not an MPI. It's just single threaded.
Okay.
Yeah, I've just I've always thought of Valgrind as looking as something you use to find memory leaks principally.
But it does detect the corruptions really nicely.
Oh, does it? Okay.
Yeah, it does a lot of, random memory badness.
All right.
Try detecting. Also, I'm going to put a configure option, which since they're going away, you might have to find the correct CMake equivalent. Let me get the chat back and opened up. And when you build with, you could try this just up front, right? And it might make the, even without Valgrind, is what I mean by that. You run configure with that option, and it kind of simplifies how HDF5's memory allocation works, and makes it, it's definitely like a requirement for Valgrind. Otherwise, it would give you weird false positive badness. But it might straighten up the memory enough that it may become easier to track down even without a tool like Valgrind.
Okay.
And which system it is? It's Windows or
Oh,
Linux?
this is running on a Linux, on Ubuntu.
Oh, okay. And it doesn't happen every time, right?
Well, no. So the suspicion is that, so we're using I think we're using szip, but not the reason we're using it is not because we're compressing data being written to the HDF5 library. What's happening is that szip has been implemented as a compression algorithm on orbit, onboard satellites.
Right.
And the data comes down in these CDSS, CCSDS packets, and it comes down compressed. And occasionally we think what's happening is that the decompression that we're executing is somehow overwriting memory that is part of HDF5. And then we don't experience the seg fault until we do an HDF5 operation.
Are you using szip, the old szip, or the szip that comes from Germany, from Climate Institute?
I'm not certain which one we're using. We may have to use one that has been approved for use with this particular data. So
I see.
yeah.
Because szip library, the one that HDF Group was supported, it was pretty. It may have problems. That's why it will be good to try another library just to see if it happens.
Okay.
I don't think we ever tested the zip library to extent that it doesn't have any issues itself.
And the name of the other one is libaec.
Okay, yeah, I noticed something. I noticed that on one of the forum things recently. So yeah, I was thinking that we might try to switch, but it would be nice to actually track down the source of this problem
Right.
Yeah, well,
as it is, because it is kind of it seems to occur when the data coming down from the satellite have some sort of corruption or pathology. It's not on, it's not on clean data. It's on data that's a little iffy. So that makes it it's kind of almost intermittent. I mean, we can reproduce it if we rerun on the same data sets. It's not intermittent in that sense, but it's not on every orbit.
yeah, you could bisect away what's the problem by comparing the szip versus the AEC builds. And the configure option I put in the chat there. Yeah.
Okay. Yeah. That may be we'll try to give that a try. Yeah, what I've done in the past to try to track these things down is I've when we've had similar experiences is I've actually gone in and explicitly closed the HDF5 interface, because that will sometimes cause buffers to flush and can trigger the problem. And then you can actually move the close around and then use that to isolate where the memory overrun is occurring. It worked in Fortran pretty well, but this is a C code, and C functions keep reopening the interface, which gets a little confusing when you're trying to do this.
Yeah, you could try, I mean, that is an option. It's kind of a blunt instrument, but you could try the H5 garbage collect to kind of force the memory use of HDF5 down as much as possible.
Oh, all right.
A bunch of those in there. That won't matter with that memchecker configure option because we don't use the garbage collection algorithms, when that particular memchecker configure option is enabled. But if you're working on bisecting exactly what the problem is, you have a couple of tools. Valgrind, I would really say Valgrind. Do the enable memchecker build with Valgrind, and you'll probably get it really quick.
Okay, well, maybe give that a try then. Yeah, thank you.
And if you need a recent develop with auto tools, I created a final auto tools develop tag.
Okay,
that will have the last configure in it.
I think we're on a fairly old version of HDF5, so we would probably just build that one.
Oh, yeah.
You know,
If you're on an old one, you have no problem.
Yeah.
And well, that's another dimension to bisect on. You could keep everything else the same and update to a later version of HDF5, including the one from Larry's branch or tag.
Okay.
And see what that did.
All right. Well, thanks for the suggestions.
Yeah.
Okay. Thank you very much. Have a good afternoon. Unless there's another question, I think we're done. So, okay.
Great. Thanks,
Bye.
Larry.
Thank
Bye,
you.
everyone.